In today's video, we're going to start looking at how we can more formally prove that triangles are congruent. So our biggest thing today isn't looking at any new rules, although we do have a few things that are a holdover from that you may have seen similar things in algebra. But more of it is let's pull the ideas together that we've already talked about and see how can we use these to form an argument. So some of our big ideas, the first three we're going to look at are actually kind of holdovers from algebra. We may talk about them a little differently when we're talking about geometric objects, but the theory is still the same as what you've used before. So our first three that we're going to look at are our reflexive, transitive, and symmetric properties. Now, reflexive property sounds a lot like reflection, and that's exactly what it is. You're kind of looking at exactly the same image. When you look in the mirror, you see a picture of yourself. When we're thinking about reflexive property, we're looking at those kinds of diagrams like what we did last time, where we have the same side being used in multiple triangles, or we have the same segment equal to itself, or the same angle equal to itself. So that's a reflexive property. And whenever you want to say something is equal to itself, and a lot of times when we have a shared side, that's when we're going to use this information. Our transitive property, you've seen this in algebra as well. Think about if A equals B and B equals C, then A equals C. And we can do the same thing with geometric objects, with measurements of angles or lengths of sides. So, and this comes right out of your algebra that you've done before. Our symmetric property is when we have to flip the order around a little bit. So if we know that segment AB is congruent to segment CD, then we could flip that around and say, well, segment CD must be congruent to segment AB. We're not going to use this as often, but it may pop up when we need to kind of rearrange our letters like we were doing when we were matching up kind of congruent pieces and diagrams. Okay, the fourth one that's kind of related to this, and we've actually already used this before, is the substitution property. Anytime we rewrite something or we substitute one measure in for something that we know is equal, we're using the substitution property. So we did this in proofs when we were looking at our parallel lines, and it's definitely going to pop up again in some examples here. All the examples on the right-hand side of this chart, let me scroll back up. These are things that we've talked about in previous units. So we have, addition or subtraction that we may need to do in math. Again, think about if you add something to both sides of an equation, you are using your addition property, or you divide both sides by 4. You're using your division property. So these are just algebraic rules that you might need to do to manipulate an equation. We've got our segment and angle addition properties, which again really just mean if you put two parts together, it makes the whole shape. So again, ideas that we've used before that are just going to start showing up a little bit more often when we're looking at these proofs. And then also don't forget your triangle congruence rules that we just talked about last class. And so those 5 rules were the SSS, side, side, side. We had side, angle, side. We had angle, side, angle. We had angle, angle, side, and we had HL. There's also some additional definitions, again, things that we've seen before that might pop up. So some of your definitions, we have midpoint and bisector, which are they go hand in hand. Midpoint is always going to be in the middle, and it's going to cut an object. That's an O object in half. And technically, a bisector can do the same thing. A bisector will cut a segment in half or an angle in half. We have perpendicular, which we might see that symbol. It also means that we have things that form 90-degree angles. We have vertical angles are always going to be congruent. And don't forget, those are always directly opposite from each other in a diagram. So we're going to see this a lot with like these bow tie diagrams that we've seen a little bit of. Linear pair, again, may not be used quite as often, but don't forget a linear pair is anything that when you put the two angles together, those adjacent angles are also supplementary. Well, supplementary just means adds to 180. And so these are different because, again, supplementary angles, they don't have to make linear pairs. They don't have to be adjacent to each other. Complementary always add up to 90 degrees. So adds to 90 degrees. And then your parallel angle pairs, especially the alternate interior angles. Alternate interior. These are what you're going to use most often, excuse me, when you're looking at these diagrams. So definitely keep an eye out for those. So let's look at 3 sample proofs. And again, just like in parallel lines, I'm not ever going to ask you to do a proof completely on your own. So you'll always have some extra help. You'll have a word bank, or you're going to be putting things in order in your proof. But I want to show you the full thought process. So that's why these proofs that we're about to look at, we're going to fill them in completely on our own, but you will always have some extra leg up to help you out on proofs. Here we go. So our first example, we are given that 2 angles are congruent, and we have to prove that 2 other angles are congruent. So not really a triangle congruence proof, but let's just get our feet wet talking about the properties that we already learned about. So let's see here. Our first expression, they gave us some information, so let's write that down. So again, first thing you always want to write in any proof is what you were given. So they gave us angle QPR is congruent to angle TPS. So let's mark it on the diagram. So QPR, if we trace around, that's our angle on the bottom. TPS is our angle towards the right. And again, use the same number of arcs or same symbol to mark those as congruent. Eventually, we need to prove that angle QPS is congruent to angle TPR. So I'm going to go ahead and write that in the very last step in my proof. Now, I don't know why that's congruent yet, but I need to know where I'm trying to go with this. And so let me make a note on my diagram just so I know what I'm trying to do. So QPS is kind of transversing these 2 angles. So think about the definitions we just talked about. One of those was angle addition property. If I can add my 2 pieces together, they make a bigger angle. Well, I could definitely do that to make angle QPS. Okay, angle TPR is the other one they want us to prove. And if, again, trace them through, so TPR, that's this angle. Wait a second. I'm starting to see something. Do those 2 angles have any overlap or anything in common? They both have that middle section. So you know what? Let's use one of those new properties that we haven't quite used yet. We're going to use the reflexive property. So we're going to say that angle RPS is congruent to angle RPS. And I can say that because if we have an angle equal to itself, that's reflexive property. Alrighty, so let's think about this. The bigger angles that I kind of highlighted, that I drew that big arc over, we had angle QPS, and we can make that angle by putting that new angle, that RPS, together with the small one they gave us. So you know what? I'm just going to add them together. And I kind of lined them up to help me out with that. So I'm going to say angle QPR plus angle RPS. Well, let's do the same thing on the other side. So angle TPS plus angle RPS. So because we knew that those angles were congruent, and we ended up adding the same angle to both sides, we added up the right-hand side and we added up the left-hand side, we are really just adding the same thing to both sides. So we could say addition property because, again, all I did was add the same thing to both sides of the equation. And then, so let's compare that to what I already have filled in for step 4. That's what we're trying to prove. So if we take QPR together with RPS, does that make the angle QPS? Well, sure. What about TPS plus RPS? That makes TPR. So if I'm adding two small angles together to make a bigger angle, what's the rule that we can use? What's our property? Again, if you need to, scroll back up to the top. If I add two small angles together, I can make a bigger angle. So that's basically angle addition. So we played around with kind of that math trick, adding the same thing to both sides of the equation. Again, not something that you might be necessarily used to thinking about, but we need to start kind of almost interchanging. If we can put parts together, it kind of works the same way as if we put equations together. Okay, let's check out another one. Okay, example 2. Now we're into some algebra, or in some geometry triangle diagrams. So we're given two pieces of information. Okay, so angle 1 is congruent to angle 2. Alrighty, so let's mark it down. And angle 1 is congruent to angle 3. Okay, so let's write these down, and I can, if I want, actually put both of these in the same step. So let's do that. So angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3. Okay, those were both given, so I can write them in the same step. If I wanted to spread them out, I could. Okay, so wait a second. With my markings on there, what else do we know also has to be congruent to each other? Well, angle 1 and 2 are congruent, angle 1 and 3 are congruent, so that means angle 2 and angle 3, they're congruent to the same thing. So wait a second. What if I said, well, if angle 1 is equal to angle 2, and I take that and I write it instead of the angle 1 I see in the other expression, what am I really doing if I'm rewriting that second idea? Back in parallel lines, when we did a rewrite, that's when we did substitution. Alrighty, so now we have angle 2 congruent to angle 3. We're trying to prove that line AB, or segment AB, is parallel to segment DC. Do we have enough information to do that? So we just stated that angle 2 and angle 3 are congruent. Do they make any special pairs of angles? One's on the left, one's on the right. They're in between our segments that we're trying to prove parallel. So those are actually alternate interior angles. So if alternate interior angles are congruent, then the lines are parallel. And again, I'm abbreviating a little bit, which is just fine, but it's still getting the full idea written down. Alrighty, so a couple review proofs. Let's check out a new one. So here's a congruent triangle proof. Okay, here we go. So example 3, RS is congruent to TS. It's already marked in the diagram, and let's go ahead and write it down. So RS is congruent to TS. Now again, if I wanted to, I could definitely write V is the midpoint of RT. I could write that down in the same line, but those ideas are so different. I'm going to choose to write them in different steps, but I can go ahead and write it. So here we go. V is midpoint of RT. And again, this info was just given to us, so that's our reason. Okay. I can't really do a whole lot with RS is congruent to TS, but if V is the midpoint of RT, what's a midpoint going to do to that segment? So V is the midpoint of RT. Oh, wait a second. What do we know about the two parts then? Well, hey, the two parts would have to be congruent. So RV is congruent to TV. And we figured that out just by thinking about the midpoint. So when that happens, you're just using a definition. So definition of midpoint. And let's go ahead and mark those congruent now. Okay, so I'm going to pause here. We're trying to prove that our triangles are congruent. Okay, I'm going to go ahead and write that in the last step just so I don't forget where I'm trying to go. Again, I don't know the reason for it quite yet. But let's think about this. Think back to the rules that we were talking about yesterday that you were practicing. We have two sides that are congruent. I don't have any information anywhere talking about angles or parallel lines, but do we have anything else in common with these two triangles? Hey, we've got that middle segment. And so that middle segment is in both triangles. And so this is the way we're going to use this. We're going to say, well, VS has to be congruent to VS. What's our rule again for something that's equal to itself? That's like you seeing yourself in the mirror, you're seeing your reflection. So this is the reflexive property. And so now that I have three sides marked in each triangle, what's our rule that we talked about last class? So that's SSS, and technically it's dealing with triangle congruence, so I'm going to say SSS congruence. All righty. So here's what I want you to do. We're going to spend 2 days on these proofs. 3 proofs alone is not enough to truly understand what's going on. You do not have a lesson check today. What I do want you to do is start practicing with some of these on the quizzes that I have linked. And so again, some of these will be asking you about triangle rules and practicing those a little bit more. Some will be just thinking, here's your proof. What could you do in this one step? So we're kind of taking baby steps on these. If this is your jam and you're working and you understand all the questions on the quizzes, you could actually work ahead to look at the practice that's in lesson 5E. But I'll be posting an additional practice video with some examples on proofs for you to watch on Monday if we still need some extra practice on those, and we'll have some additional practice assignments to work on Monday. If you do finish early, don't forget your Unit 3 test corrections are due by the end of the day, so you can also work on those. And let me know if you have any questions. See you later.